There are different bunker buster bombs of different caliber, but what sets it apart from the rest is this GBU-57, which is typically delivered by the B-2 Spirit stealth bomber. Due to the bomb's large size and weight, the aircraft can carry only 2 of these weapons in its bomb bay compartments. While it lacks thrusters, the weapon is equipped with 4 active lattice fins and a precision guidance system that enables it to glide accurately to its target using military-grade GPS. Constructed from a specially designed high-performance steel alloy, using its weight when falling under gravity to penetrate or dig itself up to 200 feet of underground soil or concrete. We'll also look into the difference between the massive ordnance penetrator and the mother of all bombs with step-by-step process of how they work, all in the video ahead. To give you an idea of the varying levels of penetration capability among different bunker buster bombs, let's compare a few examples. First, we have the BLU-109, also pronounced Blue. It is a 2,000-pound bomb developed in the 1970s. This weapon is capable of penetrating approximately 1.8 meters or about 5 feet of reinforced concrete. Next, we move on to the GBU-28, which is equipped with a laser-guided system at its front. This bomb can penetrate to a depth of nearly 6 meters, equivalent to roughly 20 feet, which is as tall as a 2-story building. However, neither of these compares to the massive capabilities of the GBU-57, also known as the Massive Ordnance Penetrator. It can penetrate over 60 meters into the ground, around 200 feet. To put that in perspective, this depth is comparable to the height of a 20-story building depending on the floor heights. These examples demonstrate the significant advancements and differences in penetration levels among these specialized weapons. Let's put an average human here against this weapon, which is 20.5 feet long, giving it a streamlined aerodynamic shape that is crucial for stability and precision. With a diameter of 31.5 inches and weighing an incredible 30,000 pounds, translating to approximately 14,000 kilograms, it utilizes its massive weight to generate the kinetic energy required for deep penetration. This heavy, compact design enables it to break through over 200 feet of reinforced concrete, making it one of the most effective bunker-busting munitions in the world. Let's take a look at the parts of this weapon. The most important part is the body casing, made of hardened ferrocobalt alloy to withstand impact. Interestingly, the body comprises more than 80% of the bomb's total weight. Inside this cover, you will find the following components. At the front is the nose fuse well, all of which are joined by a fuse conduit. Sandwiched within this rod is the explosive-filled 5,000-pound warhead, which translates to approximately 2,267 kilograms. This conduit then connects to a tail fuse, which, interestingly, is the main detonator and is crucial for delayed action. Moving to the back, nestled inside the tail, we discover the intricacies of its guidance system. Here, the inertial guidance kit collaborates seamlessly with the military-grade global positioning unit, ensuring precise navigation towards its intended target. Alongside these components, one can find the adapter ring, which facilitates the attachment of the telemetry antenna, crucial for transmitting data, as well as the encryption key battery, which safeguards sensitive information. Venturing deeper into its structure, we encounter the thermal batteries, vital for powering the system, and the composite fins, strategically positioned to aid in directing the missile towards its objective. These fins, meticulously controlled by internal gears, maneuver with precision, responding to commands to adjust the trajectory accurately. Let's take a look at the smaller bunker buster and how it works. It has a laser sensor at the front, and just behind that are adjustable fins. In the midsection, there is a warhead that weighs approximately 650 pounds, containing tritonal explosive. This is a mixture of 80% TNT and 20% aluminum powder. Finally, we have the retractable fins at the rear. To give you a better sense of its size, comparing it to a person can be helpful. The casing has a length of approximately 19 feet long, which translates to around 5 meters. This section is made of an artillery barrel, which is very strong, and has a diameter of 14.5 inches, which translates to around 37 centimeters, making it relatively narrow. They intentionally made the smaller cross-sectional area. This means the bomb displaces less material, whether earth or concrete, as it penetrates layers of reinforced bunkers or building. The smaller cross-section allows it to enter deep into buildings, potentially avoiding steel and concrete. Let's move back to the MOP and its cost factor. The development cost of the GBU-57 is estimated to be between $400 and $500 million, with its production price per unit around $3.5 million. Meanwhile, the GBU-28, a 4,000-pound bomb, costs approximately $100,000 to $150,000 per unit, while the per-unit cost of the BLU-109 is approximately $25,000 to $84,000 for each JDAM kit. Let's take a look at how this works. Step 1. The bomb deployment platform. As previously mentioned, a B-2 stealth bomber flies at a very high altitude. When the aircraft reaches the designated location and the conditions are optimal, it releases the weapon. The bomb is designed for precision, and the deployment height plays a crucial role in its trajectory and effectiveness. Then Step 2 comes the targeting precision. The bomb is outfitted with advanced guidance technology, including GPS and inertial navigation systems, which are military-grade satellites. Then comes Step 3, that is adjusting the trajectory. The guidance information and data is then transmitted to the bomb's 4-lattice motors fins located at the rear. These fins can move and adjust in real time, allowing the bomb to correct its course as it descends under the force of gravity. These adjustments are essential because the weapon does not have thrusters to change its trajectory. Instead, it relies on the movement of these fins and the high-altitude drop to control its flight path. This is why the bomb must be deployed from a very high altitude so it has enough time and distance to adjust its trajectory accurately. Here comes the most difficult part, that is Step 4, impact and penetration. The bomb, known as the Massive Ordnance Penetrator, weighs approximately 30,000 pounds, which is around 14,000 kilograms. When it reaches its target, it strikes with immense force, designed to penetrate deep into hardened structures, such as bunkers. The energy upon impact allows the bomb to bury itself over 200 feet into reinforced concrete, ensuring it delivers its payload precisely where it is intended for maximum effect. Finally, Step 5 involves the tricky part of arming the weapon. It was installed with 2 SDB fuses. Double fuses are required as a backup. The first is for G-sensing and the second is the time delay fuse. Why the redesign was necessary, it was to ensure that the bomb could strike facilities buried beneath significant layers of hardened material. For this reason, the fuses are placed at the rear of the bomb to prevent them from being damaged. Once the time delay or the G-sensing fuse reaches its destination, it can blow, creating a mini earthquake that can bury bunkers and 20-story buildings inside them. Many people often confuse the Massive Ordnance Penetrator MOP with the mother of all bombs, MOAB, which stands for Massive Ordnance Air Blast. The mother of all bombs weighs approximately 21,600 pounds and is designed to detonate above the ground, creating a massive shockwave and blast radius. However, unlike the MOP, it does not have penetration capabilities. This MOP is capable of digging up to 200 feet underground before exploding, while the Massive Ordnance Penetrator can be deployed from bombers such as the B-2 Spirit aircraft. But this is not the case with the mother of all bombs. Is so large that it must be delivered via a C-130 aircraft using a pallet system. Once deployed, the bomb is dragged by a parachute and falls under gravity, guided by an inertial navigation system and military-grade GPS. On April 13, the U.S. dropped one of its largest non-nuclear bombs on a tunnel complex in eastern Afghanistan. When it detonated, the blast sucked all the oxygen out of the caves.